Hi everyone, we are going to start a new playlist on Generative Adversarial Network, aka GAN. GANs are nowadays very famous. We all have by now come across DALI, in which we prompt some text and it generates the data in the form of images, and it. The fundamentals behind even the DALI is this GAN, and we are going to cover all this in detail in this tutorial. For the understanding of the GAN, I have divided it into three parts. In this video, we are going to have a very good understanding of what is GAN. Then in the second part, we will have a mathematical walkthrough with GAN, calculating its loss functions and how the back propagations happens in the GAN and how it updates its weights. Then we will build a Python code to generate MNIST datasets. So it is going to be a very interesting playlist, and even you can add it as a project in your resume if you all want. So let's understand what is GAN. At a very black box, as a black box, you can understand GAN is some black box in which we input some things and it generates something that is very realistic to the real data. As the name suggests, there is something what is generator, that is generative. Since there is a term adversarial, it means there is something that conflicts, that tries to fight with the generative part, and there is discriminator. Generator tries to generate the data that is close to the realistic data, and discriminator tries to say, hey generator, what you have generated is not so close to the real data, and you cannot fool me of saying that the data that you have generated is true. So generator generates something fake data and say, hey, see, the data that I have generated is real, but the discriminator tells, hey, look, the data that you have generated is not as close to the real data. So there is three components over there. Generative, that generates the data. Here the Python code that I have written, this is the data that I have generated. You can see the 8 and 5 are very close, 1, even 6 are very close, but 2 and 3, these are not so clear. Because I have run it over some 200 epochs, but if we are going to run it over thousands of epochs, then definitely the data that the generator has generated will be indistinguishable with the real data. And this is the power of GAN. And you must be very surprising to know that as an input, I have just inputted some random vectors over the generator, and it generates so close looking MNIST dataset that is so close to the real data. So generative, that generates the data, it creates a fake data. Here is this. Adversarial, the discriminator, that is a part of the GAN, it competes with the generative and say, hey, you try to fool me, but I'm not going to be fooled because the data that I have generated is fake. This is how both learns among themselves. The network term is because both the generator and the discriminator are based on either the convolutions or the neural networks having some dense layers over this. Therefore, the term is network. Here is the flow chart of how the inputs and all goes into the generator network and the discriminator. So, in the discriminator, we put real data and the fake data. So yes, you can see this is latent vector. For now, you understand latent vector as random noise that we put it in the generator network. And using this random noise, generator networks generates the fake images. Along with fake images, discriminator gets an input as fake images and the real images. Both goes into the discriminator network, and discriminator network learns that how the real images looks and how the fake images look. Along with this, the generator says, hey, the fake images that I am giving, but for the generator, this fake image is not fake, but it's real according to the generator, and says, hey discriminator, look, the image that I have generated is true, and the real images and discriminator compare the data that is given by the generator with the real data and see how close this data is to the real image. This is how the discriminator loss being calculated. And the discriminator loss goes to the discriminator that back propagates into it, and the weights get changed for the discriminator network, and also the generator loss being generated which goes back to the generator network, and generator tries to create even the more realistic data so that the discriminator cannot be able to distinguish it between the data that it has created and with the real images. So in summarizing, generator networks as an input take latent vector. Latent vector is a random noise. It generates the fake data. Discriminator network take two inputs, fake images and the real images, and see how close the fake image is to the real image, and then generates two losses. First, the discriminator loss for train itself of not being get fooled by the generator network, and the second loss is generator loss that back propagates to generator network. So the generator networks tries to create more realistic data so that the discriminator cannot be able to distinguish it between the real data and the fake data. Okay, cool. Now we have 5 steps of building GAN that we are going to cover. First, we define the GAN architecture based on the application. Suppose we are doing image segmentation. In the image segmentation, we want the labels for each of the classes. So for the generative part, we give image as an input and we want some label as an output. So for this, the generative network architecture can be unit, because unit helps in the image segmentation. So the generative network part of the for such application can be unit, and similarly we can build decoder for the discriminator part. Based on the object deductions, we can have some other architectures that we will look into this tutorial. Now, second, we train the discriminator to discriminate between the real and the fake data. Along with the data that the generator has created, we also give input discriminator the real data so that it learns how different the data generated by the generator and the real data is. Then we train the generator to fake data and to fool the discriminator. But the discriminator is smart enough to distinguish whether the image that is created is fake or not fake. And this is how we continuously train both discriminator and generator on multiple epochs. And finally, we save the generator model to create new realistic and fake data. So once the training being completed, what we want something to generate something. So once we train the whole architecture, we pull out the generative network and then we say, hey generative network, you have been trained to create such fake data that is very close to the real data. So now I am going to use you to generate something fake images by giving you inputs that is compatible with the generative network. Applications of GAN, many applications. For this, we are going to cover the image to image translations, text to image translation, and super resolutions. So this is it for this video. In the next video, we are going to see the mathematical understanding of calculating the loss functions. Then we will build some Python codes over this, and after that onwards, we will look into the image to image translation, text to image translation, and super resolutions. Thank you so much. Stay tuned for the next video.